Hello friend, so welcome to my channel. So today I am going to talk about the BGP, which is one of the very hot topic for CCNA and CCNP exam. Now you don't need to know very deeply to pass the CCNA and CCNP exam, but this is one of the uh, protocol which is not categorized into the IGP, or you can say which not fall into the IGP, Interior Gateway Protocol. So this chapter is going to be fun, so please hang with me and watch this tutorial fully. So in this tutorial I am going to introduce why we need a BGP, what is autonomous system, what are the different type of BGP, why we need external BGP and internal BGP, what are the different BGP advertisements, what is the path vector and BGP route selection. So let's begin with that, why we need BGP and where we should use the BGP. So most of the students are very confused in starting that where we use BGP. Why not every company use BGP? Even I hope many engineers work in a middle in a mid-size company or a small-size company, even in an enterprise company, but still they don't need a BGP. So that's I'm going to explain that in which situation we require BGP and where we should not use the BGP. For example, a typical network is look like this. So this is a one customer network, customer A network, and this is my ISP, and this is my internet. So my customer router is connected to ISP router. So my ISP making sure that customer A's network can access the internet um, without any issue. So his responsibility is to provide the internet access to customer A. And when the customer A take the service of any ISP of an ISP, so he provide a single public IP address. So generally, a small company basically uses single public IP address. So all the communications happen from this customer A to the internet by using this single public IP address. For example, we take that 1.1.1.1 slash let's say slash 24. So this is a single public IP address which is assigned to our customers. So do we need BGP in this scenario? No. Why? Because we just need a one default route to route all our traffic which just belong to the internet, which not belong to our networks, to my ISP router, right? And then ISP, it is ISP responsibility to route that packet to its destinations. So, and how the internal device of customer A able to access the internet, because they use a features called NAT or PAT. This is basically network or port address resolution. So for example, here I have a one desktop. I'm just taking in one example, a hypothetical example. So this is a typical setting of a small network, that on our internet router we have external NIC and internal NIC. So in an external NIC we generally configure a public IP address, and on internal NIC we use a private IP addresses. For example, this has a 192.168.1.1, and there is a switch. So a desktop, and this router is connected with the switch. So how this user is able to access the internet? So on this desktop we have a one default routing configuration, one default route configuration, that any packet which does not belong to my network, just forward it to my default gateway, which is 192.168.1.1. and when this router receives the packet, he will forward this packet to the ISP. So on this router we have a just need a one default route configuration, that any packet which does not belong to my network, or any packet which route I don't know, just forward it to my ISP. So maybe he has the other ISP side IP address is 1.1.1.2. So just forward this packet to 1.1.2. That's it. So in this case we do not need BGP, right? So this scenario is covered, I think, most of the small companies, even the mid-range companies. Now companies not only uh, provide the internet to their users, sometimes company also hosted servers, for example web server or mail server. Now these servers need to be accessed by the external user. For example, we have here an external user who is sitting here and connected to the internet. So how he will access these servers? Do we need BGP in this scenario? No. Why? Because there is a feature called port forwarding. So by using, so what is this? This is a port forwarding. So we configure the port forwarding on our router, and any traffic which comes for the web server, our router will redirect to it, right? So how this works basically, for example, um, you publish your web server to the external world with the address of your gateway. This is 1.1.1. So public IP address on this router, external IP address 1.1.1.1, right? And you make a rule in this router that if any requests come on this IP address on the port 80, just forwarded it to, for example, your web server. This web server has the IP address 192.168.1.10. okay, so here you also run your web server on port 80. So just forward the traffics to my 192.168.1.10 on port 80, where the web server. So this rule is a port forwarding rule, right? And because my router maintains this table or the connection, because it is a stateful connection, is work as a stateful connection, so he knows that when the server is reply, where he need to forward it. So in this scenario also we do not need a BGP, right? Now let's see the other scenario. Okay, so we'll take the same customer. This is customer A, our ISP, and then internet. So this is our edge router, which is connected to the ISP edge router. And within this network we have a device which is connected to a switch, and we also have our servers here, which is also connected to the switch. Now one thing you notice here, that we have, by this scenario is introduced one thing, that we have a single point of failure. So we have only one link. Okay, so what happens if this link goes down? Nobody can able to access the internet, and even the external user will not able to access my internal website. So we introduce a redundancy by just getting another link from the same ISP. Okay, now do you think here we also need a BGP? No. In general scenario, in this case, what we need to do is that we make one link as a primary link and another as a backup link, or you can say secondary link. So what typically companies do, they just use one link. What the typically, if the company's budget is not, if the company do not have big budget, so they, what they can do, they can buy one link like for 100 Mbps and one link like 20 Mbps, because every features or every service need to spend some money. So money, a budget, costing is involving everywhere. So so in this case, the company, what they can do, they can make this 100 Mbps as a primary link, and if this link goes down, they can use this 20 Mbps links as a secondary link, right? So yes, they will get a slow internet speed, but their work can go without any hassle until and unless the first link goes up. Now, so in this scenario, what we need to do, we just need to publish our, or we just need to advertise our default route into our IGP protocol, whether this is in a RAPE or OSPF or EIGRP. So within a network, we run the IGP, right? So, but how we make this link as a primary link and this link as a backup or secondary link? This is very simple. We advertise this default route. This audio is connected switch. So this, we advertise the default route within our IGP to make our primary links metric, primary link with a lower metric, and our secondary link with the higher metric, right? Now the another question come here, or you maybe think that okay, this is good, this is fine, but can we do the load balancing on this? Because my 20 Mbps link is now sitting idle here and I'm paying for this. Why not use this link also? Can we do the load balancing? Yes, sure, we can. We can do load balancing. How? Just make this two metric, primary link metric should be equal to the secondary link metric. So just make this both links metric is same, and then you can do the load balancing. But here another issue is, you can see that this is a 100 Mbps link and this is a 20 Mbps link. Okay, so this is a 100 Mbps link and this is a 20 Mbps link. If we do the load balance here, what happens? One packet goes here and then one packet goes here. Okay, so they do the round robin. So is this the ideal situation? No, this is not a right solution for us. What you will do if your if this customer A want that okay, the ratio should be 10:2. So what if I wanted to send 80% traffic on this link, 80% traffic on this link, and 20% traffic on this link, right? So that's not going to happen here, but with BGP it is possible. Okay, so in this scenario where we want this type of um, traffic manipulations, you need a BGP. Okay, now let's move to the another scenario. So this is the first scenario basically where you see when we need a BGP, where you need a different traffic load on a two link, you use the BGPs. Not for external when you have connected to the, not for internal when you have connected to an external network like ISP. Now let's begin with another scenario. So for example, this is a very interesting scenario. Let's see this. Customer A, and this is my ISP, which is connected to internet. So this is my ISP edge router, and from there I am connecting to this, and here I have my web server and email server. Okay, so the last scenario we have the same ISP with the two link. Now I have a two different link from the different ISP, right? And here is some users is sitting here with his desktop on the internet. Now in this scenario we have get the two public IP address. Okay, some public IP addresses from this ISP and some public IP addresses from this ISP. Okay, we know that by using the port forwarding we can publish our server, right? Or we can add a public IP address to our web servers and the external users can directly access to my web server. So this is the two scenario. Okay. Now the questions comes here that which ISP public IP are going to use. If you use ISP one public IP address on this server, so all user traffic will goes through this ISP1 to my server, right? If you use ISP2 public IP address for my servers, then all user traffic will goes through via ISP2. So in this scenario we are still using a only single link. So this is again a single point of failure case. So how do we come up with this issue? So instead of using the public IP addresses from the ISP, we can get our own IP address. And who give this IP address? There is an authority which is name is IANA. It is Internet Assigned Numbers Authority. So IANA is assigning IP address space to a number of large regional internet registers like RIPE. So what then? So he also allocate a IP address to a registered, which are the regional bases. One of this RIPE or ARIN, right? So each of these assign IP address space to ISP. So this RIP and ARN, they then assign this ISP. So IANA, Internet Address Number Authority, they issue the IP address to this regional register, and then they issue the IP address to this ISP. Suppose RIP assign the IP address to ISP2, or RIAN maybe assign the ISP public IP address to ISP1. Or a large, or same this regional authority can allocate the IP address to a large networks or large organizations. So when we receive our IP address space, then so I have my now public IP addresses, okay, which is not assigned to any other ISP. So what does means? This means that their routers routing tables do not have the informations about my public IP address. For example, I received 22.22.22.22 for example. So their router do not have this information 22.22.22. So for example, this IP is 1.1.1.1. So they must have an entry that okay, if you need to go 22.22.22.22 public address, you have to forward this traffic to 1.1.1.1. So this information is lack in my ISP's router, both ISP's router. Now the question is how my ISP comes to know about my public address. Here we need a BGP. So here what? Here we need a BGP. So we use the BGP on my this two router and advertise my public IP address to this ISP. And this ISP further advertise this address to the other ISP, and somehow and this and at last this IP address is assigned another ISP from which my end user is connected. And now if my end users send any traffic to 222.222.222, they have the complete path that how this packet should reach to the destination. So this is the very interesting scenario that where we need a BGP. Okay, one more case where we need a BGP is if your organization is in a transit network. Okay, so what does that mean? So let's see that also. For example, here in network A, this is network A, and this is network B, and this is your network, like customer network A. Now they are connecting like this. Okay, so now this router and this router need a BGP connection. So in this case, your network become a transit network, and when your because all the packet will go through your network. So in this case, you have to have run the BGP. Okay, so in this case, you have to have run BGP both internal and external. We will come to this point later in this tutorial. And what is the internal and external? So this is the last case where you need to run the BGP. So the conclusion of this, that where we need a BGP and where we do not need the BGP, is the two scenario. The one is if you want to manipulate the traffic in a different way, like 80% to 20%, not 50-50, Even though it is with the same ISP, then you need a BGP, because now general protocols does not allow this type of manipulations. Second, if you want to advertise your own public IP address, you have a connection with a different ISP and you want to advertise your own public IP address space to the rest of the world, then you also need a BGP. And the third scenario is if your network is in a transit network, then you also have to run a BGP, right? So these are the three scenarios where you need to run BGP. So if you see that mostly all the mid-sized companies or a or a uh, or a or a small size company, they do not require any BGP to run within their network. Now, one more scenario where you need a BGP is these days we have also do the cloud computing, and there are a lot of different cloud service provider available like AWS, Google Cloud, and Microsoft Azure. So this cloud service provider also give you the ability to connect your premises network with their networks, right? For example, this is an AWS cloud, and within the AWS cloud I have my own VPC. This is a virtual private cloud. So, and this is my on-premise network. So I want to connect this on-premise network with my VPC AWS. So what I need to do is I must have a VPN connection between these two networks, a side-to-side VPN connection. So AWS allow you to configure this side-to-side VPN in a two-way, in a static way, or second in a BGP by using a BGP protocol, right? So the benefit of the BGP protocol is that if any changes happened here, so they automatically reflect with your customer side network, customer side router, or in AWS side. So basically what I want to say that the BGP will automatically update the information. Now in the static you have to manually do that if some changes happen in their core network. I hope that you understand this clearly. If you have any doubt, please feel free to leave a question in comment section. So now let's move further. Now what is an autonomous system? So for example, this is in one network, this is in another network, this is another network. So it has autonomous system number 2, autonomous system number 3, autonomous system number 4. It is connected like this. So what are these autonomous system number with the router? So basically an autonomous system is a collection of network under a single administrative domain. So what is the single administrative domain? Means this autonomous system is basically belong to a one organization who maintain all the network of this autonomous system, right? For example, a simple example is your company's every network is maintained by you. So within you are the only domain administrator who are maintaining your network. So that's a one autonomous system, right? So the main point is here is single administrative domain under the single administrative domain. Now the internet is nothing but a bunch of autonomous systems that are connected to each other, right? So maybe this is ISP1. This can be ISP1. This is ISP2, and this is ISP3, and all these ISPs have their own autonomous number. Now, within an autonomous number systems, we use IGP, right? So within the organization, so we use a IGP's protocol. So IGP protocol, as you know, interior gateway protocol like EIGRP or RAPE or OSPF, right? So we don't use BGP because BGP is specifically made for the internet, and IGP is not so much scalable like BGP. And for BGP, and we require a powerful router, and that's depend on the what type of advertisement you are going to receive. So that is my next topic. So I hope you understand this, that what is the autonomous system number. This is very crucial to understand the BGP autonomous system. So autonomous system is a network which govern or which managed by a single administrative within a single administrative domain, right? So, and within an autonomous system we run IGP protocol, and the routing between the different autonomous systems we use EGP. So what we use? EGP, external gateway protocol, that is BGP basically. So this router and this router use EGP to communicate with each other, and suppose there is one another router and here is another router, they will use IGP protocols. Okay. Now autonomous system number is a 16-bit number. Okay, so autonomous system number also has a value which basically is 16-bit value, 2 raised to power 16. So that's give you 1 to 65,535 number. Now autonomous numbers are the two type. One is public useful, and another is private use. One for public use and another for private use. So for public use we use 1 for 64,511. So these numbers are publicly used by the different autonomous, and the private one is 64,512 to 65,535. Right. So this public autonomous system number, to get this public autonomous system number, we also need to be apply, or organization need to be apply as we do for our public IP addresses. So now you also need to ask where we use private BGP. For example, you have two branches. So you have one HO and one is branch BQ. If you want to run a BGP between these two, you can use your own private autonomous system number, okay, within your networks. But if you want to connect to an ISP, you need a public autonomous system number, because it's making sure that your autonomous system number should be unique globally. Okay. So I hope you understand this also. So now move to the another section. So let's understand this. What is the external BGP and internal BGP. The external BGP are used to connect two different autonomous system number or two different autonomous systems, right? So this is my edge router, this is my edge router. So I will run the BGP, which is known as the eBGP, external BGP between these two. Now what is the difference between this? We will talk more detail about that. An internal BGP run within an autonomous system number. So if I have there are routers, and suppose here I have also autonomous system number 3, which is connected to this. Now and there is a network, for example 3.3.3.3/24 to make this router to reach this subnet or this network or this IP address. We need to run an internal BGP on all our routers, as this is now become about transit networks, right? So okay, we will go deeply into this in upcoming video, that why we need to run internal BGP in all router within a transit network. So the thing the point you need to take from this tutorial is external BGP is the eBGP that is run between the two different autonomous system number, okay, different autonomous number or different AS, and internal BGP run within same AS. That's it. Now comes to my next topic is BGP advertisements. Okay, so this is my customer A. This is my ISP. This is my edge router connected to the ISP, right? Now you configure your customer A edge router as the eBGP with the ISP's router, which also run eBGP. So here your ISP is going to advertise the route to your router. Now what type of route you are going to accept is depend on these three type of route. One is default route. So here your ISP just advertise a default route as an external BGP to your router, right? So means you have only get a one default route for the whole internet. So for all other network addresses which you do not know, which is not exist within your router. Okay. Now the advantage is you need only single route, which is a default route. Okay. Another thing is, since you have only need a one default route, this edge router do not need to be very powerful. Okay, you can run, you can use any low budget router here also. Okay, but the disadvantage is that because you have a default route, you send all your traffic to your ISP. You do not know what is behind these ISPs. You don't have any idea about this. So you are relying on your ISP routers routing tables which will efficiently route your packet to the destination. Okay, so you depend on your ISP router for efficiently route the packet to the destination network. Now the second type of advertising is partial routing advertise. partial routing updates. So in this, what happened? So let's understand this. Okay, so let's take in another scenario. So here I have a customer A, and then here I have my ISP 1 and then ISP 2, and I have a link from both ISP, and this ISP is also connected to the internet, and the ISP is connected to like this. So for example, what happened if I use a default route? So this both ISP is advertise a default route to me, right? Now I want to send some traffic to internet. Okay, for example, some server is running on the internet. So what I do, I can forward him and him. For okay, I just forward my traffic to him, and he should send the traffic to from this way to the internet. But since I have only default route, I do not know how my ISP is going to route this traffic to the destinations. Can be he send the ISP to ISP1 can send the packet to ISP2, and then ISP2 can send the packet to the internet. So the biggest problem with the default route is that we may become a victim of a suboptimal routing. Okay, so in partial routing updates, what happened? We also so in partial routing update, what happened with the default route? We also receive some partial routing tables of ISP's customers, right? So not only he sent this default route, he also sent some partial updates of his customer plus partial updates. So in this scenario, what is the benefit? That okay, if my router want to send some traffic or send some data to a server which is running within a ISP some customers, and if I have the direct route of that customer, we can avoid this suboptimal routing, right? So just like in real life, the more you know, the better off you are. Okay, so in the world of routing, having more routing information means you can make better routing decisions. We will have less suboptimal routing problem than when we only have the default route. And the last one is the last one is a full update. I just need to rub this one. So the last one is a full update. Now in full update, what happened? The ISPs advertise the complete BGP routing table, which can hold more than 5 lakh routes. Okay, so what are the plus and minus in the last full routing updates in this scenario? In full routing update, the positive point is that I have a complete routing table, so my router can make a better decision. So as I said previously, as more information you have, you can make a better decision in routing world. But the disadvantage is that you need a more powerful router to hold such a big routing table. So you need a more powerful router which can hold this whole routing protocol. So that's put a lot of cost on your company. Okay, and I don't think for an big 500 fortune or for ISP other company need such a full routing table, right? Now the path vector. Now the next topic is the path vector. So let's start with this. What is this also? Now the path vector, so there is my operating system 1, 2, is connecting like this. So BGP is called a path vector routing protocol. What does this mean? Take a look at this image or take a look at this picture I have drawn. We have a 4 autonomous system and we are running a BGP to exchange routing information. In AS1 we have network 1.1.0 and this is advertised to AS2, 3 and 4. So we have 1.1.0 that we have advertised to AS2, AS3 and AS4. Okay, now if you look at the BGP route on your router, you can see something like this. For network 1.1.1.0/30/24 on which? On AS4, right? On AS4, if you see the BGP table that show that this network, to reach this network you have to go to the next hop, which is 2.2.2.2, and the path is basically 3, 2, 1, right? So these are basically autonomous system we have to get through in order to get to this network. So basically the path vector is basically, so in BGP we also use a path vector which basically show that what AS, these are the AS number, what AS number you need to go through to reach the destination network. So if there is a user who sit in AS4 autonomous system 4 and he want to reach 1.0.0.0 network, he need to go for AS3 and then AS2 and then he will reach to autonomous system 1. So this is called BGP path vector. So they follow the autonomous system path. Now last one is BGP route selection. So let me draw in a picture. This is my AS1 and this is my AS2, this is my AS3, AS4, AS5, AS6, AS7, AS8 and AS9, and this all AS are connecting to each other like this. Okay. Now what all BGP have common? They all have common thing that they always try to find the shortest path to the destination. But BGP work differently. Now since autonomous systems belong to the different ISP or organizations, We want to be able to selectively influence our routing. Now take a look what I have drawn here. BGP allow us to use routing policy and autonomous system label. So in this drawing I have 9 autonomous systems, and in AS9 we have a network which is basically 192.168.1.1/24. If we look, 192.168.1.0/24. Now if you look at the AS1, then we have a lot of different paths we can make. So what we can make this, and from this we can make the path from this, and this. We can also make a path like this, and this. So we have a lot of different paths we can make to reach our 192.168.1.0 network. But can we do that? The question is, can we do that? Can the administrator of AS1 do that? No. In reality, no. We cannot do that because of but why? Because of that we can choose the exit path, right? So we can choose the exit path, that what exit path you want to go, this way, this exit path, or this exit path. Okay, we cannot influence the other autonomous system routing policy. We can influence and make the routing policy for all our routing autonomous system number, right? And each autonomous system will only advertise the best path. So this autonomous system will advertise me only his best path. He also advertised me only his best path. So for AS4, maybe this is the best path to reach. So I can only influence that, okay, I want to go through the AS2, or I want to go from the AS4. If I choose the AS4, and if AS4 choose the best path that to reach this network, we should go AS5, 6, and 9. I can't do anything, right? So AS1 will only learn about the best path from AS2 and AS4. Unless their best path fails, only then you will learn about the second best path. Okay, so suppose this best path is formed, then this router find out the another best path. For example, he find the another best path is send the packet through the AS7, autonomous system 7, autonomous system 9. Now if you choose the exit path this AS4, now your packet will travel through this, right? So BGP allow us to set a different type of attribute. BGP has a lot of attributes by which we can use or select a path which we want to go. So we will cover this in my own upcoming video. I think this is enough for this session. This is too much information, I hope. And this is my first audio tutorial, and I will try to make my tutorial, or I will try to improve my tutorial further. So please, you are welcome to leave any comments if you need any further informations, or if or your valuable input will be help me to improve my further or future tutorial. So the last conclusion is that hopefully this lesson have been This lesson has been useful to understand the basic of BGP and why we use it. In another lesson, we will take a closer look at the configuration of external and the internal BGP and also how the BGP path selection works. So if you have any questions, feel free to leave a comment and have a nice day. Bye bye. I will see you in the next part of the BGP protocol.